For this session, we will talk about your time value of money, particularly your present value and your future value factors. Present value and your future value factors. But actually, it is not only present value and future value that we need to talk about in this particular type of time value. So at some point we will also talk about your perpetuity. Okay. So the following are the items we will talk today: the present value and your future value, and at the same time your perpetuity. So let's start first with your patterns of cash flow in understanding your time value of money. So time value of money, as you all know, refers to the fact that a peso today is worth more than a peso promised at same time in the future. That is your time value of money as you have learned before in your axioms. Okay? So time value, a peso today differs to the peso in the future. Now, in time value of money, we calculate the effect of this change in value. So if we have 1 peso today, how much does it worth? How much does it worth, or how much is it worth in the future? And if you have 1 peso in the future, how much is it worth today? Okay, so that's how your time value of money works. So we are now focused mainly as to the computation of how much is it in the future and how much is it in today. So if ever we are asking questions of how much is the peso in the future, we are talking about future value. Again, if we are talking, or the question is asked in a way that how much is the peso in the future, we are talking about future value. We are talking about future value. So if you have 1 peso today, how much is it in the future or after 20 years? That is a future value. Now, if you have 1 peso after 20 years, if you have 1 peso after 20 years and you want to know the value today, this is known as your present value. Okay? Present value. Okay, first, if you have 1 peso today, 1 peso today, and you need to learn how much is it in the future, we're talking about future value. So if the question is, if you invest today, how much is the worth in the future? That is a future value type problem. But if the question is, if ever you will receive 1 peso in the future, how much is the value today? We are using present value. Okay? So for example, on December 31, 2021, you will receive 500,000 pesos. And the date today is May 2021. If you want to know the value of that 500,000 pesos today, you are using present value. But if you invest 500,000 peso today and you want to learn the value in the future, let's say after 10 years, that is known as a future value. Now, in knowing your present value and your future value, you must know first the patterns of cash flow. So there are three basic patterns of cash flows. So what are those three basic patterns of cash flow? The first pattern of cash flow is a single amount. So if ever that is a single amount, meaning it is a lump sum amount, either held currently or expected at some future date. So why do we say it is held currently? When we say it is held currently, it means this is your present value, and expected at some future date, this is your future value. So held currently, expected at some future date. So at some point, you can also say that your held currently is your future value. So how much is your peso in the future that you are holding today? And you're expected at some future date, that is your present value, that how much is the value of the amount you expect in the future. But anyway, in your single amount, take note you have here a lump sum amount. Lump sum amount. When we say lump sum amount, it is one-time payment. One-time payment. Next, an annuity. A level periodic stream of cash flow. A level periodic stream of cash flow. What I need you to learn here in your annuity is that it is periodic stream, meaning it is more of installment that is equal per period. Okay, so for example of single amount, in 2025, you will receive 500,000 pesos. So that is only one amount. Uh, Example of annuity, so yearly, you will receive 5,000 pesos. Yearly, you will receive 5,000 pesos until 2030. Yearly, you will receive 5,000 pesos until 2030. Here, you have an equal installment per period. Here, you will receive it one time only, which is 2025. Here, you will receive equal amount per period, which is yearly. So 2021, you will receive 5,000. 2022, you will receive 5,000. 2023, you will receive 5,000. 2024, you will receive 5,000, and so on until 2030. However, in your single amount, 2021, you will not receive anything. 2022, you will not receive anything. 2023, you will not receive anything. 2024, you will not receive anything. But on 2025, you will receive 500,000. So what's the difference of a single amount? In single amount, you have lump sum amount, which is one-time payment only. So in our example, we will receive it only on 2025. While in an annuity, look on our example on annuity. In an annuity, you have equal installment per period. So in our example here, you will receive yearly 5,000 until 2030. So as you can see, yearly 2021 until 2030, we will receive 5,000. Okay? Next, a mixed stream. What is this mixed stream? A mixed stream is a stream of unequal periodic cash flows. Okay, so if an annuity is an equal installment per period, a mixed stream is an equal installment per period. Okay, so let's have an example of your mixed stream. Okay, let's have an example of your mixed stream. So example, 2021, you will receive 100,000. 2022, you will receive 120,000. 2023, you will receive 350,000. And 2024, you will receive 270,000. Okay, single amount, you will receive only one amount. That is on 2025. In an annuity, you will receive equal installment per period, so 2021 until 2030. In a mixed stream, you will receive an equal installment per period. An equal installment per period. So in our example, we have 2021, 100,000, 2022, 120,000, 2023, 350,000, 2024, 270,000 pesos. Okay, that's how your three basic patterns of cash flows is to be understood in your time value of money. Sir, why is it important for us to learn the pattern of cash flow? It is important for you to learn the proper pattern of cash flow to apply the proper PV or FV factor. Sir, what is PV? PV means present value. FV means future value. Okay, it is important for you to know the type of cash flow so that you know what factor you will use. Is it PV or FV factor? Let's start with your future value of cash flows. So first, what is future value? Future value is the value at a given future date of an amount placed on deposit today and earning interest at a specified rate. So take note, deposit today at a specified rate. So if you deposit today, you need to learn the amount in the future. What particular time value are we talking about? Future value. So You need to learn the value at a future date if you place a deposit today. Okay? How do we compute for the future value? We use your compounding process. We use your compounding process. Sir, what is compounding? What is compounding? Compounding refers to the process of the accumulation of interest of an investment over time to earn more interest. So this is your investment. It earns an interest, and your investment and interest also earns interest. Again, compounding, we go back here. Compounding refers to the process of the accumulation of interest of an investment over time to earn more interest. So if this is your investment, it earns interest. Your investment together with interest also earns interest. Sometimes it is known as interest on interest. Sir, why is it known as interest on interest? Because guys, at some point, we have these two types of interest. Two types of interest. Your interest can either be a simple interest and a compound interest. Right, let's have an example. So 10%, 500,000, 3 years. If that is a simple interest, so if this is the principal amount, 500,000, it will earn an interest yearly. Year 1, year 2, year 3, because you have 3 years. And that is 10%. 10% of 500,000 is 50,000. Okay? That is simple interest. Let's proceed to your compound interest. What did we say again in your process of compounding? In the process of your compounding, there is an accumulation of interest on an investment over time to earn more interest. So the interest also earns interest. So the interest earned on the reinvestment of previous interest, that's how your compounding works. So again, interest is earned by the previous reinvestment of your interest together with your principal. So for example, on year one, we have 500,000 right as principal. So since there is no reinvestment of interest, our interest is only 50,000. On year two, we have 500,000 principal right, and then we have additional 50,000 interest. So we have 550,000 already. You multiply to 10%, it is 550,000 pesos. On year three, uh, you multiplied by 10%, you have 55,000 pesos. On year three, you have initially 550 and you earn 55,000 interest again. So initially 500 earns 10% interest. And then principal 500, you reinvest the interest. It's now 550, you have another interest of 55. So 550 plus 55, you multiply it again to your interest of 10%. So we have now 550,000 plus 55,000 times 10%, we have 60,500. Okay, so that's how your compound interest works. So principal plus interest earns interest. Okay. So in year one, we have 500,000, right? We do not have interest yet, zero. That's why you multiply it to 10%, 50,000. Year two, our amount of investment is 500 and our previous interest is 50,000, 500 and 50,000. It is now 550. That will earn total interest of 10%, 55,000. So initially, 500,000 and then 50,000 plus 55,000. This is the amount in year three. So this is 605,000 times 10%, 60,500. Okay, that's how your compound interest works. Again, in future value, what process is employed? Compounding. How does compounding works? You accumulate the interest on an investment to earn more interest. So even interest earns interest. Interest on interest. Okay? So what is compound interest again? Compound interest is the interest that is earned on a given deposit and has become part of the principal at the end of specified period. Why is it part of the principal? Because as you can see, it is added to the amount of our principal. So initially, our principal here is 500,000. We added 50, and then finally, we added 55 until it is now 605,000 pesos. Okay? That's how your future value works. Interest on interest. Sir, what is a principal? Principal is the amount of money on which interest is paid. So here our principal is 500,000. You can think of your principal as an investment under your financial management. So under FinMan, we think that the principal here is the investment. Okay, investment. First, we talk about your future value of cash flows, single amount. So we use the following notation for the various inputs. We have your fair value over N, fair value N, that is your future value at the end of the period. N represents the period. P is the initial principal or the present value. I is the annual rate of interest. N is the number of periods typically in years that the money is left on deposit. Okay. The general equation for the future value of the end of period N is fair value is equal to principal times 1 plus I raised to N. So principal times 1 plus I raised to N. Okay. So in our example a while back, our principal is 500,000. Our period is 3 years and it is 10%. Okay, so let's try to compute. Future value is equal to your principal times 1 plus I raised to n. So our principal here is 500,000. You multiply it to 1 plus 10%, and our n is 3 years. Okay, so 500,000 times 1.1 raised to 3. So how much is this? 665, 500. Okay, let's check. So, year one, how much is our interest a while back, di ba? 500,000 yon. We go back on our previous example. Year one, how much is our interest? 50,000. Year two, how much is our interest? 55,000. Year three, how much is our interest? 60,500. Principal plus interest. So we need to total this one. 500,000 plus 50,000 plus 55,000 plus 60,500, we will get 665,500. So as you can see, guys, a while back when we had an example of your compounding, in which we say interest earns on interest, this is how it works under your present value of a single amount. Because the amount of principal together with the earned interest earns interest. The amount of your principal, 500,000, together with the earned interest also earns interest. So here, if you want to know the shortcut, then just use the formula. Principal times 1 plus I raised to n, raised to n. Okay? Raised to n. So our n here is 3 years. By the way, guys, for n, if ever you are using annually, then whatever is the year, that is the N. Okay? If you are using annually, whatever is the year, N. Okay? And the I is always annual. The I is always annual. Clear? I, the annual rate, kaya nga siya sinawag na annual rate is because it is annual. Therefore, guys, if ever you are asked for a semi-annual, N is equal to 2 times the number of years. Okay? N is equal to 2 times the number of years. And I is equal to your interest over 2. Again, if it's annually, Whatever is the number of years, that is N. Whatever is the interest, that is the I. However, if it's semi-annual, the N is equal to 2 times the number of years because semi-annual. So for example, 3 years. You need to know how many semi-annual are there in 3 years. What is semi-annual? Half a year. So how many half a year are there in 3 years? 1 year is composed of 2 half years. Diba? 1 year is composed of 2 half years. So if 1 year is composed of 2 half years, 1 year is 2. Second year, another 2, so 4 years. Third year, another 2, so 6 years. Or you may use our shortcut, which is for semi-annual, the N is equal to 2 times number of years. So if our number of years is 3, then our period is 6. Clear? Clear. Next. For I to compute for our I, remember I or the interest is always annual. To get for semi-annual, you need to divide it to 2 because how many periods of semi-annual are there in 1 year? 2. Therefore, to get the semi-annual rate, you need also to get the semi-annual rate. You need to divide it to 2. Clear? Semi-annual. How about quarterly? How about quarterly? If that is quarterly, to get for the N or the period, 4 multiplied by the number of years. Okay? 4 is, you need to multiply the number of years to 4 to get for the period. To get for the interest, the annual interest, you need to divide it to I. The annual interest, you need to divide it to I. Clear? Okay. Sir, why do we use 4? How many quarters are there in a year? We have 4 quarters. Why? A quarter is made up of 3 months. So how many 3 months are there in 1 year? There are 4 3 months in a year. Therefore, our quarterly fixed number here is 4. Clear? Okay, I'll write it down here. So we have here annually, semi-annually, and we have here quarterly. So to get for your period, for annually, that is your number of years. Semi-annual, 2 times number of years. Quarterly, that is 4 times number of years. Okay? To get for the interest, annually, whatever is the I. For semi-annual, I over 2. Quarterly, I over 4. Okay? I hope we are really clear as to how do we compute for these periods and interest. Okay. I here represents the interest, so it is important for you to remember this interest. I represents the interest, so it is important for you to always know how to compute for the interest. Should you use the annual interest or not? Next, N. N here represents the period. Sorry. And represents the period. So how do we compute for your period? For annually, whatever is the number of years, that is the period. For semi-annual, 2 times the number of years. For quarterly, 4 times the number of years. So remember the formula to compute for the future value, that is the principal multiplied by 1 plus interest raised to n. Principal times 1 plus I raised to n. Okay? Let's have other examples. Scarlet Witch needs to have an amount at the end of 5 years to fulfill her goal of purchasing a small sales book. She is willing to invest a lump sum today and leave the money untouched for 5 years until it grows. Figure out the amount of money Scarlet has if 10% interest is compounded annually. Okay, so here we have 10,200. What is the period? 5 years. So to compute, of course, first we need to get the principal, 10,200. You multiply it to 1 plus the interest of 10% raised to the period 5 years. Next one, 8,150 multiplied by 1 plus the interest, 5 years. And then 7,150 multiplied by 1.1, 5 years. Why again? The formula is principal multiplied by 1 plus the interest and N. What is our interest? 10%. Our N is 5. So let's compute for letter A. 10,200 times 1.1 raised to 5. So we have here 16,427.20. Next, we have 8,150 times 1.1 raised to 5. We have 13,125.66. And then we have 7,150 times 1.1 raised to 5. We have 11,515.50. Okay, so that's how we compute for your future value of a single amount. Future value of a single amount. So as you can see, guys, we only talk about your future value of single amount because actually in accounting, what is most used is the future value of a single amount. We proceed now to your present value of cash flows. Present value of cash flows. So we're done with your future value. Again, take note in your future value, you only need to know the future value of a single amount because this is the most used in accounting. Okay. Normally in your accounting problems, what is most used is the future value of your single amount. Now we go with your present value of cash flows. So what is this present value of cash flows? So under your present value of cash flows, present value is the current dollar value of a future amount. The amount of money that would have to be invested today at a given interest rate over a specified period to equal the future amount. So here, the future amount is given, you need to get the present amount. A while back, you have the present amount, you need to get the future amount. Okay? So if there's a present amount, you need to get the future amount. This is future value. If there's a future amount, you need to get the present amount. Use the present value. It is based on the idea that a dollar today is worth more than a dollar tomorrow. If future value uses compounding, present value uses discounting. If future value uses compounding, present value uses discounting. The question is, what is discounting? So discounting of cash flows is the process of finding the present values, the inverse of compounding interest. So if ever in compounding, we keep on earning interest on the interest, now we discount it to remove all the interest. So if this one is earning interest, this one we need to discount it and remove the interest so that we can get only the principal amount. Here, we have already the principal amount plus any in the interest. Right? So that is how your present value and future value works. So in your present value, take note, we use discounting. In future value, we use compounding. In your present value, this is the inverse of compounding interest. And your future value is your compounding of interest. Now here, in your present value, we use your discount rate. Discount rate is also known as your interest. Sometimes interest is known as your opportunity cost, discount rate, required return, or the cost of capital. So these are other terms for interest. Other terms for interest. That's how your present value of cash flows works. So if in future value, we only talk about your single amount, in your present value, we will talk about annuities, single amount, and your mixed amounts or mixed cash flows because all of these are used in accounting, especially in your problems. So normally problems uses these items. That's why in our topic or in our discussion today, we only focus on those time value factors in which you always encounter throughout your journey in the College of Accountancy. So present value of cash flows, let's start now with the present value of single amount. The present value or PV of some future amount to be received n periods from now, assuming an interest rate or of R is calculated as follows. So present value is equal to your future value divided by 1 plus R raised to n. Okay, so actually, what you do here in your present value, since it is the inverse, since it is the inverse, remember, in your future value, we use a positive sign. Since now in your present value, it is inverse, we use the negative sign. So how do we compute then? The amount principal multiplied by 1 plus I raised to negative n. So babalik ka kasi. Okay? Remember, you discount. So if that is the amount in the future, what is the amount today? So you need to discount it. You need to return. However, in a future value, you need to know the value in the future. That's why the n is positive. Okay, n is positive because it compounds as it goes through the different periods. However, here you need to reverse it to get to the current value. So you need to remove everything of the interest. So Rn, you need to discount it, you need to inverse it, so negative n. So principal multiplied by 1 plus I raised to negative n is your present value of a single amount. Let's have an example. Scarlet Witch needs to have an amount at the end of the 5 years to fulfill her goal of purchasing a small boat. She is willing to invest a lump sum today and leave the money untouched for 5 years until it grows. Figure out the amount of money Scarlet needs to invest today using 10% interest to receive these amounts in the future. So these are the amounts in the future, 10,200. What is the amount today? 8,150 and 7,150. Okay. So again, it is easier. You just need to get for the value 10,200 multiplied by 1 plus the interest of 10% raised to negative n. Okay? 1 plus I raised to negative n. Next, we have 8,150 multiplied by 1 plus 10% raised to negative 5. And then we have 7,150 multiplied by 1 plus 10% negative 5. Negative 5. So let's get the answers. 10,200 multiplied by 1.1 raised to negative 5. So we have here 633,333.40. Next, 8,150 times 1.1 raised to negative n. We have 5,060.51. Next, we have 7,150 times 1.1 raised to negative n. We have 4,439.59. Okay. What can you notice? In the future value from an amount, there is an increase. In a present value from an amount, there is a decrease. Okay. So here, as you can see, from 10 to it is now 6,000, 8,150, 5,000, 7,150, 4,439. This is your present value. But if we go back to your future value a while back, from 10,200, it is now 16,000 because there is a compounding. There is an increase of amount. Here, there is a decrease on amount because we need to remove the amount of interest out of that value. So out of 10,200, so this is the total principal, 10,200. You deduct the present value, 6,333.40. This is known as your unearned interest. 10,200 less 6,333.40, we have 3,866.60. This is known as your unearned interest. Why? Sir, why do we call it unearned interest? Because again, we need to remove the interest. So the difference of this one and this one is the removed interest. And what do we call that? Unearned interest. So as time pass by, the 6,333.40 will become 10,200. Okay? So please take a look and notice the difference between a present value and a future value. In a future value, there is an increase on amount, while in a present value, since you need to get the value now, there is a decrease on amount. Okay? Please remember the formula of a present value on a single amount. We go now to your annuities. So in your annuities, we will dwell mainly on your present value of your annuities. So what is an annuity? As we said a while back, an annuity is a stream of equal periodic cash flows. So remember in your equal periodic cash flows, what we mean here is an equal annual installment. Okay? What we mean here is an equal annual installment. So in your equal annual installment, we have two types of annuities. Annuities can either be ordinary annuity or an annuity due. Your annuities can either be an ordinary annuity or an annuity due. So what is the difference of ordinary annuity or annuity due? Ordinary annuity is known as an annuity in which you receive payments or the cash flow occurs at the end of each period. While annuity due is used if ever the cash flow is at the beginning of the period. Okay, so for example, today is January 1. You can collect only December 31. This is an example of ordinary annuity because it is at the end of the period. But if today is January 1, you can collect also on January 1. This is annuity due. Okay? So January 1, 2020, January 1, 2020, you will receive January 1, 2020 also annuity due. If this is December 31, 2020, ordinary annuity. Okay, so uh, let's have an example of your ordinary annuity and annuity due. So before we proceed to your example of your ordinary annuity or annuity due, first we need to know how to compute for a present value of ordinary annuity. To get for your present value of ordinary annuity, this is the formula. 1 less 1 plus I raised to negative n all over I. Okay? To get for the present value of ordinary annuity, 1, our formula is 1 less 1 plus I raised to negative n over I. Okay? Take note, you assume that the cash flow is received at the end of the period. At the end of the period. So please remove the single cash flow here. You assume that it is annual cash flow, 7,000, 28, 10, 150, and 45. So let's try to compute for this problem. So we have 4 periods, 20 periods, 12 periods, and 6 periods. Okay? So again, this is your annual cash flow, and this is your period. Okay. So for letter A, how do we compute? The amount of principal multiplied by 1 less 1.12% raised to negative 4 because that is our n. Sir, why 12? Because this is our I. Discount rate is the I. Period is n. Divided by I, which is 12%. So let's get the value of letter A. So I hope you also got this amount, 21,261.45. Next, letter B. Our amount is 28,000. You multiply it to your 1 less 1.8%, 1.08, negative 20 all over 0.08 or 8%. So let's try to compute. 274,908.30. Okay? 1.08 raised to negative 20. Okay? 274,908.30. Next, letter C. For letter C, we have here 10,000. You multiply it to 1 less 1.14 negative 12 for n divided by 0.14. 1.14 raised to negative 12 plus 1 divided by 0.14 times 10,000. Our answer is 56,602.90. Okay? Sir, it is only 10,000, but why is it 56,000? Because again, this is considered annual cash flow. So for 14 years, you will get 10,000. Actually, the total amount here is 140,000 because nga, you receive 10,000 annual cash flow. Okay? So you need to get for the present value now using present value of ordinary annuity. Next, letter D. So our discount rate is 11. So 150,000 multiplied by 1, 11, 1 less 1.11 raised to negative 6 divided by 0.11. So you will get here 634,580.68. Okay, 64,580.68. And then lastly, for letter E, this is 45,000 multiplied by the formula of 1 less 1.2 raised to negative n, which is negative 8 all over point 0.2. So the amount is 1.2 raised to negative 8, 1 less divided by point 0.2 times 45,000. 172,672.19. Okay. Again, when will you use PV of OA? If ever, it is annual installment at the end. Annual installment at the end, we use this present value of ordinary annuity. Clear? Okay. Problem 3. Tony Stark, a 25-year-old college graduate, wishes to retire at 65. To supplement other sources of retirement, He can deposit 2,000 each year into a tax-deferred individual retirement arrangement. The IRA will earn a 10% return over the next 40 years. If Tony makes annual year-end deposits of 2,000 into the IRA, how much will he have accumulated by the end of his 65th year? So our interest here is 10% and our N here is 40 years because 65 less his current age of 25, our period is 40 years. So again, you will make an annual 2,000 deposit into your IAR and how much have accumulated by the end of his 65th year. So actually, this type of problem is more of a future value of annuity, future value of annuity. So to get for this future value of annuity, the formula is equal to 1 plus interest raised to n less 1 all over interest. Future value of an annuity, 1 plus interest over raised to n less 1 over I. Okay, so we have here 2,000 multiplied by 1 plus 10% all over I raised to n. Our n is 40 all over I of 10% less 1. Okay, so we have 885,185. Okay, times 2,000, you will get 885,185. Okay, that's for problem number 3. Problem number 4, each of the mixed streams of cash flow shown in the following determine the future value at the end of the final year if deposits are made into account, paying annual interest of 12%, assuming that no withdrawals are made during the period and that the deposits are made at the end of each year and at the beginning of each year. Let's change this example by using present value instead. Determine the present value. Determine the present value of the stream of cash flows that are made into account, paying annual interest of 12%, assuming that there's no withdrawals made, blah, blah, at the end of each year and at the beginning of each year. Okay, so we have the following cash flows, year 1 to 5, and then cash flow A, cash flow B, and cash flow C. So we will answer this one after taking a break. Take a 5-minute break first, and then we will answer this. In this problem, or in this example, this is an example of a mixed stream cash flow. So let's assume that we are computing for a present value of your mixed stream, which is to be collectible at the end of the particular year for the letter A, and first one at the beginning of each year. Now, since this is a mixed stream, actually, it is a mixed single lump sum stream. Okay? So still it is unequal as to its amount. So every time it is unequal, guys, what you need to use is the present value of 1. Again, how do we compute for your present value of 1, that is principal, multiplied by 1 plus I raised to negative n. Okay, that is as to this problem. So let's try to answer this problem, especially for case A, case B, and case C. So assumption letter A. So this assumption, it is collectible on the end of the year. So end of year 1, end of year 2, end of year 3. So the I, of course, is 12%. Since it is year 0. From year 0 to year 1, how many periods? Of course, 1 year. Here, 2 periods or 2 years. Here, have 3 periods. So since we've known the interest rate now and the period, we are ready to answer the problem. So we have your 900 multiplied by 1.12 raised to negative 1. We have here 1,000 multiplied by 1.12 raised to negative 2. And then we have 1,200 multiplied by 1.12 raised to negative 3. Okay, so let's get the value of each stream. So 1.12 raised to negative 1 multiplied by 900. So this will give us 803.57. 1,000 multiplied by 1.12 raised to negative 2. We have 797.19. And then 1,200 times 1.12 raised to negative 3. We have 854.14. 803.57 plus 797.19 plus 854.14, we have here 2454.19. Okay, so that's our answer for cash flow letter A at the end of each year. Next, cash flow letter B. We have your year 1, year 2, year 3, year 4, and year 5. So 30,000, 25,000, 20,000, 10,000, and 5,000. Okay, so the periods, this one is 1, this one is 2, this one is 3, this one is 4, and this one is 5. So what we do here is we have 30,000 multiplied by 1.12 raised to negative 1, 25,000 multiplied by 1.12 raised to negative 2, 20,000 multiplied by 1.12 raised to negative 3, 10,000 multiplied by 1.12 raised to negative 4, 5,000 multiplied by 1.12 raised to negative 5. Okay. So halos pare-pareho lang naman kung ano yung ginawa natin kanina, ganun lang din naman yung gagawin natin dito. Yun nga lang, mas marami yung periods dito. And just, we need to total it. Okay? We just need to total it. So let's get first the value of year 1, 30,000 times 1.12 raised to negative 1. 26,785.71. Next, we have 25,000 times 1.12 raised to negative 2. We have 19,929.85. Then we have 20,000 times 1.12 raised to negative 3. We have 14,235.60. Next, 10,000 times 1.12 raised to negative 4. We have 6,355.18. And then we have 5,000 times 1.12 raised to negative 5, 2,837.30. Okay, we get the total of this item. So we have 26,785.71 plus 19,929.85 plus 14,235.60 plus 6,355.18 plus 2,837.13. We have 70,143.47. Okay, 7143.47. So they are almost the same. What I want you to realize here in your mixed stream is that what we will use still is the present value of 1. Okay? Present value of 1. Clear? Next, what if the stream is at the beginning of the year, meaning you receive it on January, you receive on January 1, year 1, January 1, year 2, January 1, year 3. This one is December 31, year 1, because at the end of each year. For letter B, For letter B, it is at the end, at the beginning of each year. So January 1, year 1, year 2, year 3. So take note, since it is January 1, year 1, you are taking the present value on January 1, year 1. If you receive an amount on January 1, year 1, is there a passage of time? From January 1, year 1 to January 1, year 1, is there a passage of time? None. So N is 0. From January 1, year 1 to January 1, year 2, is there a passage of time? Yes, n is equal to 1. From January 1, year 1 until January 1, year 3, how many years had passed? 2 years. Okay, so what I want you to take note here is, of course, determine the passage of time. So we are to get the value on January 1, year 1. So from January 1, year 1 to January 1, year 1, is there a passage of time? None. January 1, year 1 to January 1, year 2, is there a passage of time? 1. From January 1, year 1 to January 1, year 3, is there a passage of time? Yes, 2 years. Okay, so after getting the number of periods, we can now get for our present value. So this is 900 multiplied by 1.12 because our interest rate is still 0.12 raised to 0. Next, we have 900 multiplied by 1.12 raised to negative 1. No, the second amount is 1,000. So this should be 1,000. Next, we have 1,200 multiplied by 1.12 raised to negative 2. So any amount raised to 0 is the amount still, 900. So the second one, 1.12 raised to negative 1, 1,000 times 1.12 raised to negative 1, we have 892.86. Next, 1.12 raised to negative 2 times 1,200, we have 956.63. So how much is the total? 900 plus 892.86 plus 956.83, we have 2,749.69. So guys, remember, at the end of each year, there is a passage of time. So from January 1, year 1, which is the year 0, January 1, year 1 is the year 0. From January 1, year 1 to December 31, year 1, there is a passage of time here. But here, January 1, year 1 to January 1, year 1, no passage of time. That's why the first period is 0. Clear? Okay. If we use the case flow B, so the 30,000, this is year 0. So 30,000 multiplied by 1.12 raised to 0. And then the next cash flow is 25,000. This one is already 1. So 25,000 multiplied by 1.12 raised to negative 1, etc. Okay? So here, what I want to know, what I want you to learn here is that if the stream will start at the beginning of the year, the period is 0. You will only place a period if there is a passage of time. Okay? So we're done talking about present values and your future values. We talk about your perpetuities. Perpetuity. Okay, so what is a perpetuity? So what is a perpetuity? Actually, perpetuity is known as an annuity with continuous cash flow. Perpetuity is a continuous cash flow. So as you can see here, guys, there is a particular period of cash flows. Here, it is continuous. Therefore, period is unknown. It is perpetual. The value changes perpetually, or you collect the cash flows perpetually. So if that is perpetuity, how do we compute for that? To compute for the value of the perpetuity, you just need to get the cash flow, you divide it to the I. Okay. So for example, the perpetual cash flow is 100,000. The interest is 10%. So how much is the value of the perpetuity? The value of the perpetuity is 100,000 over 10%. So 100,000 divided by 0.10 is 1 million. That's how the present value of perpetuity works. Okay. So in perpetuity, take note there is a continuous cash flow. How to compute the cash flow over I? Cash flow over I. Okay. So let's wrap up our topic on time value of money. So we talk about your future value, particularly your future value of your single amount. So when we say it is future value of single amount again, there is only a one-time payment of that particular amount. So how do we compute for that? The principal multiplied by 1 plus I raised to positive n. I is equal to your interest, n is equal to your periods. Next, we also talk about your present value. So for present value, we talk of three items. We have your single amount, your annuity, and your mixed stream. Okay. Single amount is, of course, one-time payment. Annuity, installment, however, it is considered equal. Okay? Annuity is installment, however, it is considered equal. So first, we have single amount. This is one-time payment. Next, we have an annuity, which is considered equal installment. And then we have your mixed stream, which is your unequal installment. Okay. So if the present value is of a single amount, one-time payment, what is our formula again? So the cash flow multiplied by 1 plus I raised to negative n. For annuity, it depends whether it is an annuity due or ordinary annuity. What is the difference between an annuity due and an ordinary annuity again? For annuity due, it is collectible or payable at the beginning of the period, while annuity at the end of the period. So, annuity due, collectible or payable at the beginning of the period. So, as compared to ordinary annuity, it is at the end of the period. So, how do we compute for the ordinary annuity again? 1 less 1 plus I raised to negative n all over I. How about for annuity due? Annuity due. For annuity due, it is 1 less 1 plus I raised to negative n less 1 raised to negative n less 1 all over I plus 1. Okay? 1 less 1 plus I raised to negative n less 1 all over I plus 1. So if ever n is equal to 3, I is equal to 12, how do we compute for that? So it is 1 less 1.12 raised to negative 3 less 1 all over zero point 0.12 plus 1. So this will become negative 2. Okay, that's how it works for annuity 2. While for ordinary annuity, we had an example a while back already on this one. 1 less 1 plus I raised to negative n all over I. Take note, there is an equal installment. If there is an unequal installment, mixed stream, you use again your present value of 1. Present value of 1. So we call this one your single amount, present value of 1. This one is your present value of annuity due. This one is present value of ordinary annuity. Here we use again your present value of 1. 1 plus I raised to negative n. Okay. By the way, the formulas The CF here is known as your principal or your cash flow. And the 1 plus I, the items with 1 plus I raised to negative n, this one is known as your present value factor or your future value factor. This one is known as your future value factor. This one is your present value factor, present value factor, present value factor, present value factor. This one is the cash flow. So if ever you will hear or see problems which says the present value factor of ordinary annuity, it is computed using this item. Present value of 1, it is computed using this item. Okay, what I want you to know, always take note of this. You will need this also in your AE 105 on when will you use a particular factor. Future value, if ever, again, you need only to know the future value of an amount. Present value, if you need to know the amount now, you need to know the amount now or the amount today. If ever that is a single payment or one-time payment, you use your present value of 1. That is 1 plus I raised to negative n. If you have equal installment and the installment is at the beginning, you use present value of annuity due. If ever you have annuity again, equal installment, at the end, you use present value of ordinary annuity, 1 less 1 plus I raised to negative n all over I. And if that is mixed stream, unequal installment, you use your PV of 1, 1 plus I raised to negative n. Finally, if that is a perpetuity, meaning continuous cash flow, that is cash flow all over I only. Cash flow all over I only. So we have three here: fair value, present value, and perpetuity. The items I discussed on your time value of money today is purely those items that you will always encounter as you go through your college journey in the College of Accountancy. So I want you to always remember when to use this present value and future value factors, including this perpetuity. Always remember when to use it, because the problem will not tell you what to use as to a time value factor. It is up to you to determine what time value factor will you use. Is it present value? Is it future value? Is it perpetuity? Is it value of 1? Is it ordinary annuity or annuity due, etc.? You should know when to use them. So here we already outline it. And furthermore, we had examples. And also, you have here the formula based on your scientific calculator. I'm sorry if ever I taught this topic using scientific calculator, because that is what is used by most of you. But actually, in actual practice, especially on the board exam, you should use a basic calculator. Okay, on the board exam soon, you are not allowed to use a scientific calculator, but you will only use a basic calculator. So please also study how to make use a basic calculator. I'll try to find a video in YouTube which thoughts for a basic calculator time value computation, and I could share it with you or in your class later once I find a YouTube video tutorial. But please, again, place your focus on these items on our wrap up. Whatever is placed here, this you will use, I'm sure of it, as you go through your college journey. And again, I want you to remember when to use these items. So please, please, please memorize this one, know the formula so that you will not get lost on how to compute these amounts. Furthermore, in your upcoming quizzes, on your exams, on your activities, I will not give you what particular factor you will use. It is up to you on how you will determine what factor you will use. Is it the future value, or is it the present value of 1, present value of annuity due, or ordinary annuity, whatever. So it's up to you to determine what time value factor you will use. I hope we are clear. And that's it for our time value of money.